All right, guys. So the past few days, we've been looking at the law of sines. So how we can use the sine function to solve triangles. So now we're going to look at the other option that we have is the law of cosines. So how we can use cosine to be able to solve triangles. So what I want you guys to take a look at is this triangle that we have here at the top of the page. So what we're given is we're just given a regular triangle labeled how we usually label things with a height drawn. So what I want to look at first is I want to look at what we know about the relationships of the sides of this triangle here on the left. So since this is a right triangle, we know that we are going to the side lengths are going to follow the Pythagorean theorem. So we know that x squared plus h squared equals c squared. Okay, and what about this other triangle over here on the right side? Well, again, it's a right triangle. So we know this one's a little bit different because we know that b minus x squared plus h squared equals a squared. So I want to take a look at how can these two relationships help in help in solving this triangle. So first I want to simplify this right one here. So I want to take a look at this. So I'm going to simplify this squared here. So I have, b squared minus 2bx plus x squared. And then I have my plus h squared equals a squared. Well, if you guys notice, right here, I have an x squared plus h squared, which I also have over here. So what I can do is I could substitute in that c, since this is equal to c, I could substitute that in right here. And I could say now I have b squared minus 2bx plus c squared equals a squared. So the next thing I want to do is I want to just get this in terms of my overall triangle. So I want to just get this in terms of A, B, C, and my angles A, B, C. So that means I have to try to get rid of this x here. So I want to figure out what is x. So if I want to look from angle A, because that's what triangle this is in, I would want to look at my adjacent. So I could take a look at the cosine of A, which is equal to adjacent over hypotenuse. So I know that x is equal to c times the cosine of A. So now what I have, if I substitute what I just solved for in for x, now I could have everything just in terms of my side lengths and my angles. So I'm going to have b squared minus 2b times c cosine of A plus c squared equals a squared. And then I want to just kind of clean this up. So what this is saying is that one of my side lengths squared equals one of the other side lengths squared plus the third side length squared minus 2bc times the cosine of A. So really, I know that this wasn't a very intuitive process that we went through here, but really what we looked at is we looked at the two right triangles formed using the height of our overall triangle. So we know that we can use the Pythagorean theorem to find the relationship of all three side lengths. And then if I wanted to just solve this triangle in terms of my side lengths A, B, C, and my angles A, B, C, I would have to solve for X and substitute that value in. So I'm left with this relationship here. So what that relationship is that is my law of cosine. So I have a squared equals b squared plus c squared minus 2bc cosine of A. Well, the nice thing about this is that it actually works for all three of my different side lengths. So if I wanted to get b squared, I would just switch my b's and my a's. So I would have a squared plus c squared minus 2ac cosine of b. And the same way, if I wanted to find c squared, I would just switch my b and my c. So I would have a squared plus b squared minus 2ab cosine of c. So really what I'm looking at is that this relationship works for any side length in terms of that angle and the other two sides. So I want to do just 3 quick examples using this law of cosine, and then I will let you guys get some practice. And so today and tomorrow is just all practice. Well, I guess today and Monday is just all practice, and next week is mostly practice with this law of sines and law of cosines. So let's take a look. In this problem, I am looking for the measure of angle A, the measure of angle C, and my side length of B. I'm just going to put that little answer bubble right there so that I can keep track of it. So if I'm wanting to use my law of cosines, the first thing that I want to notice is that I do need an angle measure for the law of cosines. So if I want to solve this, I need to look at what angle am I given. I'm given angle B. So that means I want to look at my cosine for, or my law of cosines for B. So I want to look at this middle one here. So I'm going to solve for b squared, which I don't know what b is, so that's good. So I could say b squared equals a squared, so 7 squared, plus c squared, so 5 squared, minus 2, 7 times 5 times the cosine of 100. So I just substitute in those values because I know that 7 is my A and 5 is my C. So if I just type this into my calculator and I simplify it down, I get that b squared equals 86.16. I take the square root, so b is, I guess these are approximately, it's not exactly, so approximately 9.28. So 9.28. Okay, so now I solved for B. Now I want to solve for A or C. And the nice thing about this is now that I have a side and an angle, I could continue to use the law of cosines, but this one is really messy. So what I'm going to do is I'm going to switch over to using my law of sines. So I'm going to use that the sine of 100 over 9.28, and I'm going to use that to solve my angle A and my angle C. So I'm just going to alphabetical order solve for the sine of A first. So the sine of A over 7. Do my cross products. So the sine of A and then times 9.28 equals 7 times the sine of 100. The sine of A equals 7 times the sine of 100 over 9.28. So the inverse sine, you have to take the inverse sine of both sides. So A, let's do that. Let's do the inverse sine of both sides. So A is approximately, let's see, 47.95 degrees. 47.95 degrees. So then for the measure of angle C, I can just do 180 minus 100 minus 47.95. Get that C is approximately, let's look. C is approximately 32.05 degrees. So 32.05. So that's how we're going to use our law of cosines. So we don't have to always just use the law of cosines or just use the law of sines. We can kind of look at a mixture of the two. So the next problem, instead of being given sides and angles, we're just given side lengths. So on this one, we're looking for the measure of angle A, the measure of angle B, and the measure of angle C. So it really doesn't matter which one we start with. I'm just going to start alphabetical order. I'm going to start with A. So I want to look at, this is my A value, my B value, and my C value. So I'm going to look at my law of cosines and see that I want A squared equals B squared plus C squared minus 2BC times the cosine of A. All right, so what I can do here is I can just go ahead and simplify. If I do 10.5 squared, I get 110.25. 3.6 squared is 39.69 plus 144 minus 2 times 6.3 times 12 is 151.2 times the cosine of A. So then I'm going to subtract 39.69 and 144 over to the other side. and get that this is negative 73.44 equals negative 151.2 times the cosine of A. Divide both sides by 151.2, and I get that the cosine of A equals negative 73.44 over negative 151.2. Then I'm going to scooch on over here. So then I'm going to look at the inverse cosine of what I just found, which is approximately 61 degrees. So A is 61. Now that I know one angle and its side length, now I could just switch over to using my law of sines. So I can solve for angle B by doing that the sine of A over A equals the sine of B over B. Do my cross products. So 10.5 times the sine of B equals 6.3 times the sine of 61. Divide both sides by 10.5. So 6.3 times the sine of 61 divided by 10.5. Do the inverse sine of both sides and find that B is approximately 32 degrees. B is 32. And then I could just do 180 minus these two and find that C is approximately 87 degrees. And there we go. So what I want you guys to do is I want you guys to pause the video and try number 3, and then I'm gonna go through it with you here in just a second. So pause the video and try it. Okay, number 3 says a pilot is flying from Houston to Oklahoma City to avoid a thunderstorm. The pilot flies 28 degrees off of the direction of the route for a distance of 175 miles. He then makes a turn and flies straight onto Oklahoma City. To the nearest mile, how much further than the direct route was a route taken by the pilot? So what we're looking at is this is our direct route here from Oklahoma City to Houston. We had to take a little detour and turn on these 2 points. So really what I'm trying to find is how long was this route from my turning point to Oklahoma City so that I could figure out how much farther it was than my original. So I am given 2 sides and an angle. So I'm looking for x. So if I use my law of cosines, I'm going to have x squared equals one of my side lengths squared, so 396 squared, plus my other side lengths squared, so 175 squared, minus 2 times 396 times 175 times the cosine of the angle opposite of the side I'm solving for. So the cosine of 28. So I can really just plug all of this into my calculator and find that x squared equals 65064.46. And this just says to the nearest mile, so I really don't need that decimal. but I'm going to keep it just so when I take the square root, I get that I'm approximately 225 miles. So 225. So how much farther than the direct route was the route taken? So my direct route would have been 396. So the route that I took was 175 plus 225. I want to add those together, subtract what my direct route would have been, and I could find that it was only 4 miles further. All right, guys, so that is it for today. So go ahead and practice, ask any questions that you guys have, and I will talk to you guys again next week.